Well, hello and welcome to the editing room. I'm AJ O'Neill, your Beyond Code instructor. What you're about to watch was extracted from a live mentorship session on loops. I'm just going to keep that in there. This is part of a playlist which you can find in the doobly-doo. Now this bit is actually more of a bonus reel. It's on why arrays started zero, and I kind of give this comparison with a music box. TLDR, it's because C-style languages were meant for hardware, not for applications. That said, when we say zero, but zero is first and one is second and two is third, it's hard to talk around. The reason is very simple. Have you seen a music box?
Yes.
Let me see if I can pull up an image real quick of a music box scroll here. This is how a circuit works, a circuit with electricity. It works the same way that a music box does. So cranking the handle on a music box gives you a cycle. It gives you hertz. Now, typically for music, we don't count music in hertz. We count music in measures, and we count measures in, I don't know how you count tempo, but there are units of measure for music that we don't use for electronics. But when you have one full turn of the handle in electronics, we would call that hertz. So if you have gigahertz, that's billion turns of the handle. And as you can see here, there's these little clips and there's a spring mechanism inside. And so when the hole punch goes through the mechanism as the handle is being turned, it will produce a sound because the spring mechanism will then clang with the thing that is underneath it or above it or whatever it is. There's a little pin or something, and the crank of the handle will, I believe in this case, the crank of the handle pushes the pins down and then releases them at regular intervals on the gear. And when the paper is in the way, you don't hear the ding, but when the hole punch is there, you hear the ding.
Mm-hmm.
So, assuming that we understand the basic principle of a music box, the way that the electricity in a computer works is basically literally millions to billions of these types of little electronic pieces inside of the computer that either can be in an on state or an off state. And very much like this, they have an addressing mechanism where you could say how many could be present or not present at any given time. Does that make sense?
Yes.
So we could have a hole punch, here, all the way across, and that would be an electrical connection. So on a circuit board, there is what we call multiplexing, which means that, this is best shown, why do we have a 12 base numbering system? Well, very simple. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 base numbering system because we have 12, I don't know if knuckle is the right word. We have 12 places where you can count on your finger. So if you want to count on one finger, you can count to 12. Well, if you were to count in binary, then on one finger you can count, I think, up to 32, because you can do 1, 2, 3, 4, 5, 6, 7, and so on. So this is the first path, is when there's nothing there. So when you multiplex and you have a completely blank line like this one where there are no hole punches, that is a valid address for where the electrical signal will go. So a circuit board operates on a principle that an electrical signal is there or not there, and you count based on whether the electrical signal is present. And when there are no electrical signals present, that is the very first pathway. And any electrical signal that you introduce is a different pathway. But the very first pathway is when you open nothing, and that is a valid pathway. That is not the thing being turned off by an off switch. That is selecting the 0th pathway. Does that make sense?
Yes.
That is why arrays start at 0, because languages like C are not designed to operate in applications. They're designed to operate on circuit boards. So when you access a memory address in C, you are literally accessing a physical wire on a circuit board somewhere in the computer. Now, there's layers of abstraction on that, but in total, when you say, I want the 0th area of memory, that's saying for this section, I want to select no open electrical connections and access the memory that is at that pathway.
Okay.
So that is that. And there are multiple languages that no longer follow those old conventions, and they just start at 1 because in a modern language, you don't program circuit boards, you program software. But for the most part, languages choose 0 because of legacy, and it is sometimes simpler to have just one system rather than have 2 systems, even if the second system is more rational for the application. So that was the bonus round here. I hope that that was enlightening to some degree and eliminates some element of confusion.
Yes, it helps.
All right. Thanks for watching. Go ahead and give this a big thumbs up if you just watched the whole thing or if you found any part of this to be useful for you. Also, don't forget to click subscribe and ring the bell if you'd like more like this. I do live streams every weekday, which is uploaded to the live stream channel in the description. And I also upload the edited versions to the Beyond Code Bootcamp channel, also in the description. Adios.